In this video, let's discuss about or and and. So these are two words that you will see in many questions related to probability. And we have already seen this in the case of fundamental principle of counting when we discuss permutation and combination. Alright, now let's take an example to understand these very well. Say a dice is rolled. Alright, and let's define two events. Event A is the event where a multiple of 2 is the outcome. Event B is the event where a multiple of 3 is the outcome. So what are the possibilities where event A is satisfied? We could get 2, 4 or 6 as the outcome of rolling the die, right? And what about event B? The cases where event B is satisfied is when 3 or 6 is obtained when you roll the die. Alright, now whenever you do some type of questions in probability, it's very helpful to draw a diagram, and you can see more of this in Venn diagram section. But over here, let's quickly understand only what is required in the case of probability questions. Alright, now we can draw all the possibilities that when you roll the die, right? These are 1, 2, etc. up to 6. These can be represented like this in a diagram. Alright, so the universe of possibilities, that is 1, 2, 3, 4, 5, 6 is drawn like this. Now inside this universe, let's draw event A, which is the possibility where a multiple of 2 is obtained when the dice is rolled. Now let's draw event B inside this universe. That's like this, right? Over here you can see that there is an intersection between event A and event B, right? Why is that so? You can see that one of the outcomes, which is getting 6, is occurring both in event A and event B. That's why we draw it like this, where there is an intersection between event A and event B. Alright, now let's mark these outcomes inside their respective events. So 2 and 4 is over here, 6 is in the intersection part, and 3 is over here. And what are the remaining events? We have covered 2, 4, 6, 3, right? So 1 and 5 remains. So they are drawn outside. And as we said, this over here represents the universe of events, that is all the possible outcomes. Alright, let's keep that aside. Drawing this type of a figure is helpful in many questions in probability. And this is something that we borrow from Venn diagrams, right? Now let's move on. Say we want to find out the probability of getting event A and event B. What is the probability of event A and event B satisfied, right? This can also be written as probability of A intersection B, right? That's written like this, A intersection B, and that is equal to 1 by 6, right? Because there is one outcome where A and B are satisfied, that's this outcome of getting a 6, and there are 6 possibilities, right, that can happen, which is the total number of outcomes, which is 1 to 6. So favorable by total is 1 by 6. That's the probability of getting A and B satisfied, or the probability of A intersection B. Alright, now over here you can see that what we did is, from the diagram it's very easy to understand that we just find the intersection. That's where A and B occur. Now what about A or B? What is the probability of A or B occurring? That would be the probability of A union B, which is equal to 4 by 6. Over here this stands for union. And what are the cases where A or B is satisfied? If you get 2, 4, 3 or 6, 6 is common, right? So 1, 2, 3, 4. There are 4 possibilities where A or B is satisfied, and we have seen over here there are a total of 6 possibilities that can happen. So the probability of A or B happening is 4 by 6. And from the diagram you can see that what we try to find out is this space, that is the whole area over here covered. How many events occur in this space? That's 1, 2, 3, 4. We have 4 events. That's why we have a 4 over here. And in the universe we have 6 events. That's why we have 6 over here. So the probability of A or B happening is A union B, and that is equal to 4 by 6. Let's quickly revise. When you have and, you find the intersection. When you have OR, you find the union, and the union is this space over here. The intersection is the common space, which is this space over here, where we have seen that we have only 6. All right, now let's also learn one more thing about probability of A union B. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Let's see whether that is true. What is the probability of A? We have 3 favorable events. So probability of A is 3 by 6. What about probability of B? We have 2 favorable events. So probability of B will be 2 by 6. And what about probability of A intersection B? We have seen that we have 1 favorable event. So that's 1 by 6. Therefore, this over here is equal to 3 by 6 plus 2 by 6 minus 1 by 6, which gives us 4 by 6, which is exactly what we got over here. All right. Now, over here, why is it that we subtract the intersection part? You can see that if you add A and if you add B, you will add this part over here 2 times because it's part of A and it is part of B. But we want it only 1 time because remember, only this shaded area is the favorable section. In that, you just need to add the intersection 1 time. So because you added 2 times when you do PA plus PB, that's why we subtract 1 part of it. That's why we have to subtract probability of A intersection B over here 1 time. Let's move on. There is an interesting method with which we can find the probability of A and B occurring. That is P of A into P of B. Over here, this is applicable when A and B are independent events. Alright, now what do I mean with independent events? That is, the outcome A is not at all dependent on whether B is happening or not. Over here you can see that these 2 events are independent. Whether you get a multiple of 2 or a multiple of 3, you're just throwing the dice 1 time. Therefore, these 2 events are independent. The probability to get a multiple of 2 is 3 by 6, right? Because we have 3 favorable events. And 3 by 6 is equal to 1 by 2. Similarly, over here, the probability to get a multiple of 3 is 2 by 6, which is equal to 1 by 3. Now, if you multiply these 2, that's 1 by 2 into 1 by 3, which is equal to 1 by 6. And that's what we've got over here as the probability of A intersection B. Remember, probability of A and B is the same as probability of A intersection B. Let's discuss quickly one more example where this is applicable. Say you have 2 people X and Y and they are trying to shoot at a target. The probability that X will hit the target is 0.2 and the probability that Y will hit the target is 0.3. Now the probability that X and Y will hit the target will be 0.2 into 0.3 as per what we have seen over here, and that will be 0.06. In this case also you can note that X hitting the target and Y hitting the target are totally independent of each other. That is, if X hits the target or does not hit the target, it does not in any way affect Y hitting the target or not hitting the target.